So we do industrial inspections in GPS-denied environments with Emerson Hovermap to provide 3D point clouds, or we use the Helios 2, which is behind me. We do visual inspections. We turn that into photogrammetric models. Some of the companies we use are Flyability, Emerson. We're partnered with RMUS. We have access to the Spot robot from Boston Dynamics. We've been using them for a number of months and have been the first ones in Canada to take it underground. And we have quite a few big name clients from different parts of North America. We've been in a lot of different situations involving a lot of different aspects of mines and mine infrastructure. So the laser scanning, we use the Emerson Hovermap to create a 3D point cloud of environment. This is useful in the mine to be able to measure volumetrics and be able to capture a scene to monitor change detection and a lot of different aspects of the infrastructure they're using. It also affects the safety. There's a lot of places that people can't access within these places of the mines that they don't know what's happening. And if there's a question of something going on in the mine, then they need to stop and pause and just take a step back for safety, right? So this is the Emerson Hovermap, weighs a couple kilos. It's a SLAM-based LiDAR. It's a mobile LiDAR unit. Gives us 1 to 3 centimeters of accuracy. Allows for collision avoidance on the drone in the sense that we can fly it into something and it knows that there's an obstacle in the way and won't allow you to fly into it. It will also allow for waypoint mapping in GPS-denied environments. It can build a 3D model on a tablet and show you where it's going, the flight planning it's doing, and return autonomously. This is an example of one of the environments that we'd be flying into. You can see there's a lot of stuff that hangs down. So it can see obstacles down to 1 millimeter. We're talking like little thin wire, blast wire, commonly used in the mine, messenger cable, aircraft cable, things that might be hanging down and be an obstacle. On the left side, we see a vent bag. In the middle, we see those cables. On the right side at the top, we see a cross section of the stope that we flew through. This is an area that's totally inaccessible. They do it remote from the bottom with a scoop tram. They muck out whatever's been blasted from the top. Nobody's ever allowed to set foot in this. Previously, they would try and set boom poles out from the top and balance it and try and keep it still and capture an image to get the volume of the stope. And then a lot of important numbers from the mine come off of this volume, we'll say. A lot of people rely on this number from the mill process to the mine itself to know that, yes, we shipped this much ore, we had this much waste. So we can help with this volume. Here's a flight path of what the drone would do during a mission to capture a full dense point cloud. We can get a shadowless, they call it, point cloud based on like our drones moving through the environment. We don't have to set on those boom poles and let it sit and look around. So it's not really a fair comparison to the previous technology. We're able to take this simple flight plan within 7 minutes and turn it into a 15 centimeter mesh, which is more than enough for the mine, and georeference it so that it sits within real world space. And more examples of the mesh and different ramps, different color intensities we can apply to for different things that they might want to see. If there's change detection applied, or if they're worried about things sloughing off, we can show that pretty easily. Another good application is Orepasses. These are hard abused areas in the mine. There's ore and waste passes. They take the dump trucks and they just pour it down into a deep hole, typically 700 to 1,000 feet long, 4 or 5 meter wide hole. And it changes as the ore or the waste runs through it. The dynamics of it will change. It's almost like a river carving through the rocks over time. So yearly, they like to have these inspected. So we will provide them with this. There's no other way of accessing this at all, other than with the rigs that we use and the scanner that we have helps. There's other ones available, but we believe that the Emerson has the best SLAM LiDAR on the market today. It's the best mobile option. So in this case, we didn't have it on the drone. We had it on a cart that just slid down these long holes on a rope to capture these point clouds for the client. Without this, they wouldn't know what's going on at the bottom. There's a lot of different scenarios that could happen around these ore passes. As the size grows, it could approach different parts of infrastructure that you may not want it to. So we can georeference it all together and show a physical distance that's going on between different parts of the mine. And this is an example of the point cloud that we would give. So on the left, we're looking at the mesh and a cutaway. On the right, we're looking at the actual point cloud that the unit would capture. This is the Grizzly. So this is where you would actually access the Orepass from. They typically have, so it's the first stage of screening for the ore. So some mines have underground crushers, some don't. So depending on the size of the Grizzly and the opening, the equipment can only meet a certain like a certain dimension. So we're constrained to whatever the size of that hole is. Our gear also has to fit in there, be protected from the environment, have some sort of telemetry feedback, have video link, and also be protected from water because our unit's not IP rated. We can also get into bins. So this was just hanging it down on a rope off a crane. We used our own rope and used the crane just kind of as a shiv down. Within a few minutes, we were able to scan this whole thing without having to send anybody down into a bosun's chair or any other means of scaffolding to get into it. It's very, very quick. And a cross section of the same to give kind of an idea if there's changed movement, the volume of it. In this case, they were kind of looking at the plates. So, yeah, it's a good example. Drifts and ramps. So there's a lot of ramps underground. So in order to connect levels, you have to go through different areas and you have to drive a corkscrew down to the next level. And it typically is offset to the ore body so that you don't encroach on any sort of unstable ground that you might want to blast out later. So we'll, again, this doesn't have to be the drone, right? We'll take the SLAM-based mobile LiDAR and put it on a vehicle. We can just magnet it on. We have a way of capturing these point clouds quickly and efficiently on ramps in enclosed environments and then registering it to actual coordinates. An example of a whole mine that we quickly did. I couldn't even tell you how many kilometers this is, but it's a good example of how many levels and what kind of infrastructure we're dealing with, and the complex challenges of the LiDAR and the SLAM, and the challenges it has to overcome with the matching. We'll say different things are going on here. More views of the same ramp or different ramps, and the actual point cloud of the same. We make sure everything's aligned properly. We can unfold it. We can do cross sections. In one example, we had a client was looking to fit a piece of equipment through the ramp. So they were looking for collision detection around corners, anywhere that it might be a problem to get it through. We could slide it through that model and it'll give them kind of an insight as to where it may not work too well for them. Another good example of those cross sections we can give off the point clouds. A good thick, dense point cloud, very accurate, within 1 to 3 centimeters of accuracy. Very good for underground structures. So it's not just inaccessible places. Sometimes you want to see what's going on around your main infrastructure. Sometimes you want to do as-builts. Will this piece of equipment fit into this cavern, right? So we can do crushers and different pieces of underground infrastructure, major things that they might want to assemble or put into process. In this case, it was a head frame. The alternative was setting up about a week's worth of scaffolding to go up and look at certain beam pockets. And about 10 minutes, we could walk up and down and give them enough of a point cloud to do some measurements of what they needed. And a couple of more views of this same point cloud. So not only are we capturing the area they want, we're giving them more data actually than what they could even imagine. And turning it into a mesh as well. And cross sections, yeah. So this is a fly through that we would do. So the client likes to be able to give their boss basically some nice, concise data that doesn't take a lot to digest, without having to go through a billion points and looking at it and analyzing it. It's very easy in the software to take our point clouds and remove the rocks, show just the infrastructure, or just show the bare earth and separate those layers of what they want to see. In this case, was a tank that a very very large tank that had a bladder inside and a floating lid is what you see at the bottom. Built many years ago. Prints were lost or destroyed or forgotten, and contractors were given the task of going in and repairing this thing. So we launched an M200 and flew in here with the mobile LiDAR for a few minutes, just one battery, and was able to capture a full shadowless point cloud. And more examples of tanks, quick volumes to understand. So in addition, we do the visual inspection. We have an E2. It's a 4K camera, photogrammetric models. Allows us to get into some pretty tight spots that the big drone can't with the LiDAR. Collision tolerant. It's made of a series of pentagons, all kind of zip tied together. It's like a 250 mil drone frame inside with a really good camera, really good lighting, and excellent software. So with the position hold of that thing, we can get it into places and up into tight areas that you wouldn't expect. Anything under 18 inches, really 16 inches. We can get into stuff where it might take a week to do scaffolding. We can go and look at it with a camera in 2 minutes, right? One of the underground environments here of what we'd be flying into. We'll take some of this stuff and align it to the LiDAR. So with the photogrammetric models, it doesn't give us a really good scale of what's going on. So we use the LiDAR to supplement some of that data, and then we can scale whatever we can't reach with the LiDAR. So in this case, the drone, like the LiDAR drone, is just too big to fit in. So we use the Helios. Our pilot's very skilled. He can fly into very tight spots with water dripping on his camera and somehow pull a model out of this through the software that we're using. This would be a totally off-limits spot in a mine. It'd be stupid to go underneath something that's just got hanging rock, obviously. And then we also get into some pretty dry spots, big caverns, again, that and active caverns that the big drone will fit in, that is still data is required. So without sending in a drone, that unknown will shut down a mine. It costs them a lot of money. So we're able to provide a valuable service and give them what they need. This is one of the photogrammetric models we're getting off of the Helios. I believe it's one of our, it's our partner in Montana that took this of his adit. He has a training adit that's attached to his office where you can show people how to fly and show off some of the capabilities of the systems that we're using. Very good model. I think there's a couple of batteries, maybe one battery. The onboard lighting of the E2 is amazing. More than enough light to provide this kind of model in an underground environment. We're talking absolute darkness where you can't see your hand in front of your face. We can clearly see all the services running to the side. Some of the rock mechanics holding it all together, the screen. We're looking up into some of the places that may have fallen previously that have been repaired. Just an incredible model that comes off of this drone. In this case, in the bottom was water. So it's hard to fill in, but it's still capable of showing the rest of it.
It looks to me like in Prometheus, where they get that little ball and they kind of throw it, and that's exactly what you guys do.
Yeah, absolutely. That's what our laser scanner allows us to do. We can set waypoints on a DJI product to autonomously go up to 10 kilometers away. We'll return to home, monitors the battery dynamically, builds a point cloud on on a tablet so that we can just tap to fly while it's moving around inside of the mine. Don't even need video link, don't need DJI link, don't need anything. This SLAM-based LiDAR takes care of everything.
Does it all. And what's the reception like for if you, I mean, does the guy or pilot, do they have like goggles and kind of like flying around? What's the range on it all like?
It sucks. It runs off Wi-Fi, believe it or not. So because we're restricted to how much power we can put underground. So the beauty of this thing is you don't need to have any sort of signal. You can tap beyond what it can see and it will go or won't go. If it can't, it will return to home.
Interesting. Yeah, wow.
Yeah, it's very intriguing.
It looks like your camera doesn't track a lot of dirt when it's flying in those dry and dusty environments in the caves. How did you achieve that?
So that's props to Flyability. We're the service guys, so we partnered with a lot of different companies to give us a broad angle into the mines. So we have the gear that can get into any sort of situation. So Flyability makes an excellent drone, and we want to have the best for our clients. So that's what we use.
How did you come up with the drone inspection business idea? Was the business born out of your personal hobbies? Is it a continuation of a colleague's project?
Okay. Yeah, so that's Matt McKinnon. He had a real passion for drones and a real passion for mining. So he started to put the two together. He found partners, may or may not have worked. He found some other partners and did what he had to do to get into those spots. And then that was about 5 years ago. About 3 years ago, I got involved with it. I had a lot of heavy industrial experience, underground experience. I started building drones about 8 years ago, so I had a really good handle and concept on how they worked. I got in a little bit of photogrammetry at that time too. So I met him just by chance, and it's been all history since. So,
what tips would you have for those who are thinking of starting a drone startup today? Which types of services should they focus on?
Well, that depends on what you're interested in, really. If you like mapping, do mapping. If you like photogrammetry, if you like GIS, like whatever, right? So pick an interest. If you want to inspect roofs, do that. If you like flying drones, just fly the drone, really.
What is your biggest challenge, problem, roadblock you encounter as a drone business?
Breaking into the industry. Mining is very tough. It's all word of mouth. People can't just show up at a mine. I mean, it's not flying a drone at a park. We have the gear, we have the experience, we have the people. We have all the contracts. Like, we have the right things in place to be doing this, and we're very confident in our abilities and our skills. So it's difficult to get into in what we're doing.
What is the range and FOV of the LiDAR being used? And is there a favorite that you like to use, or do you have a different for different use cases?
Yeah, so we put our money on the Emerson horse. We're using the Emerson Hovermap right now. It's 80 to 100 meters. It's using a Velodyne 16, so I believe it's 30-degree angle, and 80 to 100 meters. Gives us 1 to 3 centimeters of accuracy, which is pretty good for mobile. You have to consider it's moving around. It's not just a stationary sitting there with zero coordinates. So
you have a lot of components on that drone. I'm curious as to how you manage to flight the missions.
So it's all through the Emerson software. They have an app that goes along with the firmware they're using on the payload that ties into the SDK, the DJI software. And so we just run the firmware and the software on an Android tablet. And then, we can see the point cloud in real time and just tap away. And
how many sizes of drones do you guys have? I just kind of had questions myself there. I mean, you were talking about, I kind of gathered there's maybe kind of two, a bigger one and a smaller one.
Yeah, the LiDAR needs a bigger one because it weighs a couple kilos, right? So you can put it on a M600, 300. I prefer the 210. Emerson's working on their own drone right now. But it's all going to be within that same, I think it's 120 mil footprint. It's a cross between getting into the places and being able to lift what you want it to lift and be able to fly for as long as you want it to as well.
I know you mentioned DJI. I've been threatening to buy a drone, and I think I'm going to do it.
They're a lot of fun. Yeah.
Yeah, man, definitely. I know there's some kind of like drone laws, have to be like 50 meters away from a person, a property, house, blah, blah, blah. Do Emerson, are they in just kind of commercial drones? Do they do kind of personal use drones as well?
No, well, Emerson's more the enterprise level, we'll say. It's
Sure.
built around mining.
Mhm.
SLAM works really well in an enclosed environment, and
Mhm.
mines just happen to be very enclosed.
Mhm.
So, yeah, it's a natural fit. They designed it right around all the uses that they need it for underground.